So, hello everyone. First, I have a very good news for everyone. We only are 30 minutes away from the lunch. So, with that in mind, let's get started. Yes, unlocking Kubernetes for the edge. My name is Ali Alp, and I'm a principal software architect at BrainLab. And if you scan that QR code, you can get the slides. So, yeah, and certificates. So in terms of things, so I'm a software architect, so I ask questions for living. So I start the talk also with a question: what problem we are trying to solve with the Internet of Things? And to dig more deeper into that question is that why the problem exists in the first place. So let's dive into an example. Let's say that what are the IoTs? They are devices that they are measuring the environment with some methods like a temperature device, and then report that data constantly to somewhere. And why we need them is because we want more efficiency. And I mean, efficiency in the industrial environment. Let's say that we are in a factory, and inside the factory, let's say that we have some possibility of leakage of a toxic gas or something. And we want to protect our employees, so we mandate everyone wears a wristband, that we monitor their vital. If they fall or faint, we will understand, and hopefully, and then someone will go and help them, right, immediately. And, well, if we lose employees, it's not a good thing. We lose revenue. Other people will be scared to work in that place, so we lose money. And in order to achieve the efficiency, we need observability. And that's the wristband, right? We observe how are they doing. And, and that is the reason the observability gives us proactivity. So we can maybe even have a temperature meter to tell us that, oh, it's too hot, so turn on the fan, right? So with this having in mind, I want to give a little context about the industrial environment, what we are talking about. Two things comes to my mind, minimum, when I'm talking about the industrial environment. One is it's remote, right? So for pollution, for noise, and all this stuff, they put the industrial places out of the city, right? And that brings two issues. One is network connectivity, because GSM providers, network providers, they try to have a good service in the places that there are more people, right? And therefore, the network has a high latency, and also maybe sometimes there is no, right? And also commuting to that place is hard. For a technician to get there, he needs maybe his own car. There is no bus getting there because it's a remote place, right? And the other thing is that it's big, right? A factory, a place that it comes to mind is a big place that they make big stuff or small stuff, a lot of them, right? And how we will make an efficient industrial environment. So today, we need a lot of IoT devices, right? If we are going to measure these wristbands, every employee needs one of them. Or if it's a thermometer, we need a lot of them scattered all over the place. And all over the place means a lot of them. And we need to analyze the data that these devices are generating. So we are dealing with a lot of data. And based on that data, we need to make smart decisions and fast. If the guy is on the ground because of a gas leakage, we need to do something fast, otherwise the guy will die, right? So what is the problem, to get to the question? The problem is actually to efficiently analyze high-intensity data streams over poor network connection at low cost. So this is something that it shouts no cloud, right? Because the cloud is, you need a good network connectivity, and you don't do well if you don't have money, right? So for that, we came up with the solution of edge computing, right? Which is basically taking the computing power and putting it into the premise, right? So this assists addressing external connectivity issue, because right now the server or the node or whatever is located literally, physically inside that factory. We also assist with the problem of too much data, because the thermometer, maybe it's shouting every second that it's 15 degree, it's 15 degree, it's 15 degree. But we don't need all that data. We need meaningful data, which is when it's 15, when it gets 16, let me know that it's 1 degree changed, right? So we can aggregate this data and make more meaningful data, that the size of the data that we are going to send it to the cloud will be little. A new solution brings a new problem, maintenance. So we brought these devices, these nodes, these computer servers into the premise. And we said that that place is remote, right? And we said that that place doesn't have good network connectivity with a lot of latency. So remote maintenance, maybe not a very possible idea. Physical maintenance, maybe hard to get there. Having an IT department there, I don't know about you guys, but normally a place that there is not too much going on, because how many edge nodes you're going to put there, right? So there is not a lot of work, no internet. These two, no work, no internet, so I don't think the IT guy will be happy to live there. Oh, wait, but we have something cool called Kubernetes, right? It's highly available, scalable, secure, resilient, and fault-tolerant, extensible, and monitorable and observable. So why not we use the extensibility and build something specific for the cloud, right? That's the idea. But let's think about that for a second. Let's dig into each feature that it provides us. High availability in the cloud. What we do, Kubernetes has control plane and worker nodes, right? So let's just put multiple control planes. Let's do the etcd, have replicated data. They select their leader. One of them is writing the data of the API gateway, API server, and the others are replicated. So we have 3 API servers. Cool, everything is fine. And let's do 10 instances of our application on worker nodes. And we have 5 on one node, 5 on other node. One node goes down. What happens is that Kubernetes waits for a while, say that there's a long time, there is no news from the kubelet from the other guy. Something is wrong. So maybe I should put 5 more instances on the healthy one. So we manage the high availability in the cloud like that. But what about the edge? So there are internal connectivity issues. Like literally, there are big obstacles, metallic, in a factory, that it jams or reflects the Wi-Fi signal. And maybe you don't get a good connectivity. And the LAN, maybe it will be hit by a person, because it's not a data center. The network is not secure. Maybe the cable is passing from a place that it can be disconnected. Or someone just curious and unplug it. And so we have synchronization issues. And high availability, all these API servers that they need to synchronize all the time together, they may not be able to see each other. And there can be limited number of physical nodes. I was very polite to say there is this problem, because that's the definition of the edge, right? You don't want to put the whole data center on the edge. So there will be limited number of the physical servers. And why physical? Why not VM? Because you literally need a distributed system. On the cloud, you just right-click and say 5 more nodes. And what are they? VMs, right? But if you put one server, physical server, and put on top of it 5 VMs, if, I don't know, a ladder fall on the server, you lose all your VMs, right? So you need literally physical servers that they are not in one location because they can get damaged or something. So you scatter them throughout the factory. And the other problem is smart scheduling. You may say that, oh, wait, I will write a very cool scheduler for Kubernetes. It's extensible, and I will be very smart about it. But the thing is that the IoT devices can move, right? And maybe the decision that you have made and wrote your smart scheduling is not going to fit with the moving things because they are sensitive about the latency. Maybe you are talking about the real-time devices that they need very low latency, and that low latency comes with the actually connecting to the closest node. And there, you need to be able to measure this to find out which node is literally, physically closer to the. And as I said, technician visit is hard or impossible sometimes because maybe the environment is toxic or forbidden to go, simply. Yeah. Scalability. There's a question mark there because personally, I think Kubernetes is not scalable. And what I mean by that is, I think Kubernetes is eventually scalable. I think maybe you heard of eventual consistency. So this is similar to that term, eventual scalability. I have an article, you can read about it. And so pod is doing its thing, it's processing, doing its thing, and then the CPU usage goes up, the memory goes up, and then the metric server is collecting this information on an interval, right? And then what happens is that after a while, the HPA, the horizontal autoscaler, is watching, right? Is watching that the metrics that coming from the metric server and say that this pod is not doing very well, right? After a while, and then it says that I need to do something about it. And the administrator obviously previously did some configuration in the HPA that if, first of all, you need to figure out the weird units of CPU and memory in Kubernetes, because percentage doesn't exist, you know, and normal megabyte and gigabyte doesn't exist. It's I don't even say the name. So you need to figure that out, and based on that, you make a configuration that if the load is above this, bring up new pods. And then Kubernetes finally decided that, okay, it's time to bring some pods up, right? And then the pods needs to wake up. And it takes time until they get a liveliness probe, or readiness probe. And everything goes fine, you get 5 new pods. So it doesn't react at the moment, but it reacts eventually. And on edge, what we need is a fast reaction, because the devices are moving and they need to, maybe they go to on a node that they need to connect to a node that node needs more pods at that time. You may say that, why don't you use KEDA, for example, to make it event-based? That when there is more connection, you have a faster reaction. So it increases the resource consumption, which is not a good thing on the edge, because you have literally limited number of servers there. And more maintenance issue. KEDA is based on an external event source. It needs to receive the event source to make its decision. And as I said, you need dynamic scheduling. So this dynamically changing HPA and KEDA, I mean, if you did configure HPA, you know that you need to sit and watch the workload for a while to understand that when is the right time to spin up new pods, right? You need to sit and say that, okay, 60% CPU is, not a percent, but after you convert everything. And it's not a good idea to dynamically do that. It may fail, and that failure causes a single point of failure for the horizontal pod autoscaling. And cluster autoscaling, nada, because you don't have any more nodes, literally, physically. Someone needs to go there, put a device, connect it to the network, configure it, and then you have a new node. Security. Yes, in the cloud, we have all these cool features, role-based access control, namespace, network policy, secret, and all this cool stuff we have. But on the edge, people have physical access to both network and the node. Physical, it means that at night, the guy can put the small, the edge computers are pretty small mini PCs, put it in his wallet, not wallet, but in his backpack, and then go home and have fun with it, Or the network, you can just unplug things, So it's not like the cloud that everything is secure and no one can enter to the data center. Resilience and fault tolerance. Self-healing. I don't know. Old times, when I was a system administrator, what I was doing was when they were complaining the service is not working, I was killing it and then restarting it, and everyone was happy. And no one called me a healer, But Kubernetes is self-healing, replication and high availability, we talked about that. Service and network resilience, pod disruption budget, node health, cluster auto-scaling, distributed and decentralized control, persistent storage with high availability. Okay, we need to talk about this. So, database and Kubernetes. I don't know about you, but some years ago, when I was younger, when we were installing a physical server for a database, and then installing the operation system, installing the database engine, and there was the time that we were going to create a database and give a data path to that database engine, right? How many of you think that it's a good idea, or let's make it backward. How many of you do you think that it's a bad idea to plug one flash drive and give the data path for that database on that flash drive? How many of you do you think that's a bad idea? Okay, I'm really relieved. Thank you. So if you are interested, I have another article about that I'm comparing literally PVC with the flash drive, okay? And what problems you can face that are very, very similar, like dangling volumes that no one can attach it. Even if you attach it, it cannot be mounted. Even if you mount it, you cannot reuse it because the data is corrupted, because while it was writing, the CSI controller suddenly went AWOL. So we need to redesign for edge. All the things that we mentioned normally works in the cloud easily. And let's talk about, again, the persistence storage with high availability on edge. As an example, what we need is a real time means real time, right? So the storage should be maybe literally located on the node, because we need real-time write and read. And something that is missing right now is dynamic provisioning on-premise. Who is going to do that? In the cloud, if you don't define, if you don't have a persistence volume ready to be used by PVCs, then you need to dynamically provision it, and the cloud is taking care of that. But who will do that on-premise? Who will do that on the edge? And maybe we need resilient, distributed, native file system. Maybe the Kubernetes needs its own file system. And the data security on edge is much more important than in the cloud, because in the cloud, you may be able to secure, as I said, people have literally physical access to the node. Extensible. What have we done with extensibility? Sometimes extensibility can be a danger, So if you want to design a motorcycle, and now you want to design an engine for the motorcycle, picking a car engine and trying to squeeze it on the motorcycle, it's not a good idea, right? And if you take the Kubernetes and scrape off all the features, make it in one binary, and say no to etcd and use even SQLite or whatever you use, right? It's not always gonna do exactly what you're expecting. Maybe we need to look into the requirements again. Monitoring and observability. in the cloud, we have telemetry collection, health check, auto-scaling metrics. We have Istio, Jaeger, we have HBAs working, Elastic Stack. We can connect that to the CloudWatch or whatever you use, or security compliances monitoring, Falco, and stuff like that. But on the edge, what we need is real-time monitoring. What does it mean? Right now, you open the Grafana, right? And you are looking, you never say that this metric is 2 seconds late, right? You never say that. You don't even know that when exactly that metric arrived to the server. You're gonna create some alerts, right? Some alerts that maybe can save someone's life, like the wristband, right? So monitoring is something important on the edge. It's not just metrics. Those metrics, they have different values. And the monitoring stacks that we have at the moment, they have a lot of overhead. Yes, they are scraping again. They are lightweight version of stuff for the edge. Another thing is that industry-wide telemetry standard. Every IoT device, because they are being created by different companies, they have their own idea of logging or making their metrics. And OpenTelemetry did something very cool that made it common for most of the applications that you now stick to the OpenTelemetry and don't need to care about how it will be digested. We need something like that. Instead of putting a pipeline to just convert the events that are coming from the IoT devices to something understandable by Kubernetes, we need the industry-wide telemetry standard that they generate the data in the first place digestible by the Kubernetes or anyone who understands telemetry standard. We have telemetry fragmentation, which maybe you have multiple clusters in one facility, and then these guys maybe go offline or they have high latency and you don't receive the events that are coming from them. So you don't know how to make the correct decision if some part of the data is missing, is not being synchronized yet. And something like log security, because as I said, logs on the edge, they may have different value. It's not only metric that you just look at it whenever you have a problem. Maybe they have values like there are some wristbands that there is no news from them, right? And maybe we need to figure out what's wrong. Maybe it's crushed under something, right? Maybe the guy is under something and in pain. So what is the gap? So edge needs a solution that is lightweight and resource efficient. And when I say lightweight, I mean by heart, not scraping down. Kubernetes is a fantastic project which is working perfectly in the cloud, which is designed for the cloud, which is a project that is designed for stateless applications. And maybe we need something that is lightweight and resource efficient by heart, like what happened in Android. It is a Linux-based system, but it's being tuned for a low resource consumption, battery-optimized system. We need to be able to support unstable connectivity. Maybe TCP is not a good idea. Maybe we need something like Quick. Maybe we need something entirely different. And we need to have in mind real-time and low latency on the edge. And self-healing and resilience, self-healing, these concepts maybe needs to be re-implemented because there is a different perspective over what is not okay on the edge. Because one node may try to contact the other node, and after a while, it doesn't get the answer. It doesn't mean necessarily that the node is down, right? Maybe the healthiness is a different concept on the edge. And we need advanced security because people, they have physical access to the network and the node. And scalability for the multi-cluster, because that is the concept that is being handled normally by third parties, but it needs more native support for the edge purposes. And aware of the edge-specific networking and capable of ML. So right now, the world is going this direction, and the Kubernetes is way behind, in my opinion. And it needs to go toward the direction that AI is by heart supported by Kubernetes, not something that you put on top of it, because when you put things on top of Kubernetes, you add to the abstractions, and you increase the latency. And on the edge, you have sometimes real-time applications that they cannot tolerate latency, and provides the observability and analytics that it deserves, so with the lightweighted and ability to make quick decisions fast. So Kubernetes on edge. Of course, Kubernetes and the tooling around it are convenient, but the solution to every problem is not a new SIG, right? In Cloud Foundation, what is happening normally is that whatever new problem comes, we create a special interest group and try to fix it with the already having solution in hand because it's convenient. So I leave you all with the question that Kubernetes on edge, a new use case or a new project. Thank you.
Thanks a lot, Ali. Is there any question for him? Come on, there one. Do you want the microphone? No? Okay.
Could you answer your own question? What would you say is?
Yeah, in my opinion, it is a new project because it has a different requirement. So if you look at the Kubernetes in the cloud, the base idea behind it was to have something like an operation system for the data center, right? You don't have a data center on edge. And everything that it's already being resolved, like you want more resources, done. You want a high-speed network, done. None of them exist on the edge. So it has a different requirement, and just by scraping off the feature of it, it won't be enough, in my opinion. You will end up at the end with a different product. You change this again and again and again and again, and you see that, oh man, nothing remains from the actual thing. So in my opinion, it is a new project. Thank you.
There was a question there. Yeah.
For me, I am coming from the development of production control systems initially 20 years ago, and these systems are running really in real time. So it's not a soft real time, it's a real time with microseconds reaction. So I don't believe like Kubernetes can achieve this at all. Why do we need a Kubernetes on edge for such power? Like from our use cases, what we run, or we can run on Kubernetes is something non-critical, which can should run on edge, do some data messaging, and then transfer to the cloud. But why do you see you need real-time requirements to Kubernetes?
If I understood your question correctly, what you are saying is that you are not using Kubernetes right now on edge, or do you?
No, we have some connector, and it's kind of Docker images running on edge, but the only purpose is to get the data from the real-time system and deliver it to cloud, maybe do some messaging.
Yeah, I understand.
What are use cases for real-time? Why do you have this requirement for real-time?
So the thing is that the features that Kubernetes is bringing, they are so nice, so convenient. Something like that you can rely on Kubernetes for self-healing, that it takes care of the workload, and if there is something wrong, to bring up new services, and the ability to have a single stack, like you have these Kubernetes on the edge, and then these Kubernetes are federated, and then you have another Kubernetes that managing these Kubernetes. So it gives you a lot of tooling and a lot of features out of the box. There are projects like KubeEdge. There are projects that there are even people using K3s on edge for these purposes. And the industry is moving toward that direction to be able to manage and leave the system offline and leave it and be at rest that they will continue working, even if they are not online. And the ability that these Kubernetes clusters will synchronize together later on whenever they have connectivity, and you will have a more autonomous infrastructure. So there is a need, and people are going toward that. But what I am arguing here is that maybe we needed maybe we need to look into the requirement more deeply before we stack up things on top of Kubernetes for the edge. Thank you.
And we have another question there.
Yeah, so my question would be, so you just talked about the stack. So do you think all of the problems are actually coming from Kubernetes itself, or maybe some of the issues are actually related to your like OCI container runtime, your ContainerD or whatever you're using, right? So because it sounds like maybe some of the issues actually come from containers, we might need something else. And in theory, you could run something else even with Kubernetes, even if you don't use containers. Right?
Yeah. So very good question. The question is that maybe the problem is not in the Kubernetes, but more deeper, maybe it's the container runtime. And in my opinion, that's a very valid point, and that's something that's, there should be a different variety of container runtime for the edge, because you have different environment. There, you are not going to put only a RESTful service there. It's an endpoint maybe that is going to be connected to multiple IoT devices. Maybe it needs to have a different life cycle. Maybe it needs to have a different way of being alive, right? So in my opinion, yes, that is actually my message, which is to look into the requirement and maybe saying that, okay, there is a cool architectural ideology in Kubernetes. Let's use some of them. And maybe the Docker, maybe the container runtime, whatever you use, maybe it has some cool ideology behind that, but we are going to work somewhere completely resource limited with bad network connectivity, which is all against something that it's mostly being abstracted by Kubernetes in the cloud, so you don't feel them, but when you go to the edge, you actually start feeling them and realizing them. So I absolutely on the same page with you. Yeah.
Any other question? We have one there.
On the same lines, if you're just thinking about the container interfaces, how about the Wasm runtime? Will it be helpful?
How about the?
Wasm runtime, WebAssembly.
Yeah.
That might be a faster solution.
Yeah, maybe, yes. So ideas like this, for example, to brainstorm and to figure out that what is a good way to go from the base level. You know, maybe as I said, maybe the TCP is not a good idea in the first place, because it has a lot of TCP and packet loss. You know, that don't go together very well. So it needs to retransmit, and so maybe there are newer protocols. Maybe that should be the protocol that it will be used. Maybe WebAssembly, maybe a new container runtime. But what I'm trying to say here is that we have a completely different requirement. And trying to squeeze already shiny with all the feature sets Kubernetes into this is not gonna always work.